Okay. So lastly, we had used the last type of interaction of three lines, three straight lines, where they are meeting at three different intersecting points. And the first time we got here as a closed figure. And since it has three vertices, we'll call it triangle. And we also proved that in a triangle, all the sum of angles would be 180 degree. How did we do it? So we took a parallel line parallel to BC, and then from the theory of parallel line, this particular angle will be equal to B, and this particular angle equal to C, and this angle is A. And since all these three are angle at one side of the straight line, so that's why A plus B plus C would be 180 degree. Okay. Now there is a very easy extension of this particular theory is if I'll extend a line in a triangle, so I'll have an external angle, and let's say it is A plus B plus C, and this particular angle is external of C, external angle of C. So external angle of C, yeah, I will mark it as like external of C will be equal to A plus B. Why? Because I know that C plus A plus B is equal to 180. And I also know that C plus external of C, like this particular, these two angles, C plus external of C will also be 180. Okay. So with these two results, I can get this result that external of C is equal to A plus B, because in both of the equations C is common. So these two must be equal. And you can see in this graph also. So sometimes you might get a very easy question that if this angle is 40, this is 130, then what will be this angle? So you know that if it is x, so we know that 40 plus x is equal to 130 and x is equal to 90 degree. Okay. So this was one simple result which was an extension of the result of sum of all angles. Now, before going to talk about different type of triangles, let's talk about little about polygons also. So I was saying that when three different lines will interact or intersect as three different places, I'll be getting one triangle. And if there are four lines and if they are intersecting at four different points, I'll be getting a quadrilateral. And we have five different lines which are interacting at five different points, we'll get pentagon. So this is how we'll get different size or different polygons with different number of sides. So all these are called polygons. So we'll be learning a lot about polygons later, but first let's go back to the triangle first, because I think you need to know more about triangles than other polygons. And once you'll study about triangles, studying polygons will be easy. So the only result that I have till now is that sum of all the angles of uh, triangles is 180 degree. आप लोग बीच में भी कुछ हमसे पूछ सकते हो if you want, ठीक है? If there is any doubt, you can intervene the class in between also. If no doubt, you can just go ahead with the, we can just go ahead with the flow. So now we can categorize triangles in two way. One with respect to angles, and other with respect to sides. So if there is 190 degree in a triangle, there is 190 degree. If A or any particular angle is 90, then we have B and C both will have equal to 90. So if there is 190 degree, we'll call this triangle as right angle triangle. Right angled triangle. You don't have to write D here. Right angle triangle. So a triangle will not have two right angles. It will have only one, or it may have only one right angle. And if there is any right angle in the triangle, it will call right angle triangle. And there is a very unique property related to this particular right angle triangle. These two sides, one of them will be called perpendicular or one of them will be called base. And it will be represented as P and B. And the third side, which is the biggest side, it will be called hypotenuse. So there are two things. When a particular side will be called perpendicular, why can't we call this side as perpendicular? We can call this side also as a perpendicular, this side also as base. So to tell any particular line is perpendicular, we take reference of the angle for which we are talking about. Let's say if there is a right angle triangle in which one angle is 90 and there are other two angles as alpha and beta. So if we're taking the reference of beta, the perpendicular is the opposite to the angle. Then this will be perpendicular and base will be the line which is adjacent to the beta angle. And if we'll take alpha as a reference angle, then this particular line will act as perpendicular and that particular line will act as base. So I think you know it. For beta angle, ABC is the name of the right angle. Then for beta angle, BC is base and AB is perpendicular. So anyway, whatsoever side is this, P or B, the result, this P square plus B square is equal to H square. This will hold true for all the right angles. So if you don't want to get confused, you can just say that the two lines which makes or which creates the right angle, which is A and B, let's say I'm naming them A and B, and the third line is C, then A square plus B square is equal to C square. And if any three numbers satisfies this particular equation, they will make a right angle triangle only. Let's say if there are three numbers 5, 12, and 13. And what you can check here now that 5 square plus 12 square is 25 plus 144, it will be 169, and it is 13 square. So this particular result matches with the Pythagorean triplet. So we'll call it a Pythagorean triplet. This particular theorem is called Pythagoras theorem. And any three integer, when they follow the Pythagorean theorems, we'll call it Pythagorean triplet. And any such triplet will make a right angle triangle. So if you draw a triangle like this, if you take a side of 5 and then you will take a side of 12 and then you take the third side as this, which will be 13, it will always be a right angle triangle where right angle will lie between 5 and the 12 line. So any Pythagorean triplet, if exist, it will form a right angle triangle. So just to give in reference, like 3, 4, 5 is the most basic Pythagorean triplet. And any multiple of this will also be a Pythagorean triplet, like 6, 8, 10 will also be a Pythagorean triplet. So all the right angle will follow the result and all the Pythagorean triplet will make also a right angle. So this is what you have to remember with right angles triangle. Then another type of triangle is when one of the angle is more than 90 and of course less than 180. So if there is an angle, let's say this is an angle which is more than 90. So if one angle is more than 90, this particular triangle will be called obtuse triangle. And if all the angles are less than 90, less than 90, this triangle will be called acute triangle. Okay. So this you have to remember that when a particular triangle is obtuse and when a particular triangle is acute. And I believe that you all know now is what is a right angle triangle. If we'll categorize the triangle with respect to side, we again have three type of triangles. One, when all sides are equal. So such type of triangle will be called equilateral triangle. Equilateral triangle. When two sides are equal, it will be called isosceles triangle. And if all the three sides are different in sizes, it will be called a scalene. Okay. So these three type of triangles are there. Before explaining any of these three, let me talk about another result also. If we will make a triangle, anything like this, and let's say A, B, C. So what we say that the side which is in front of angle A, it will be called a small a. Side which is in front of B, we'll call it small b, and then a small c. And if angle A is greater than angle B and angle B is greater than angle C, then the side A is greater than B and greater than C. So what I'm trying to say here is larger the angle, then larger the side. Of course, in front of the side which is in front of the angle. But what you have to remember here is that this is not proportional. This is not proportional. This is not proportional. Like, let's say if there is a triangle like this, 30, 60, 90, and the sides are in ratio. Of course, I'll write the exact ratio here, but probably you might not know this ratio. What will be the ratio of the sides if the angles are in 30, 60, 90? So what you can see here is that this angle gets doubled, but side doesn't. Here, what you can see that this angle gets tripled, but side doesn't get triple. But of course, larger the angle, larger the side. So this result holds true, but it is not proportional. Okay. So you will remember that it will never be proportional. So now let me give you another key learning here, that let's say we have two sides of a triangle. One is 5 and second one is 12. Let's take the same two sides of a triangle. Then what could be the measure of third side so that we can make a triangle? So can we make a triangle with taking 4 as x or not? I'm talking about the restriction of the size of sides while making a triangle. Okay. See, all the results which are getting, only those results you need to remember actually. Since I am teaching here, I'll be explaining a lot because uh, I should be explaining the results also. But if you're not getting the result, matlab explanation, you can just remember the results. What are the key results that we are getting? So in order to explain this situation, what I'll do, I'll take a side 12 and I'll also take a side 5 on the same line. So this is 5 and this is 12. So what you can see here is, if I'll take the third side of 7 from this place, so it will actually, what will happen, the stick of 12 will lie under, and stick of 5 and 7 will coincide on 12 to meet each other. So if anything, any side which is less than or equal to 7, it can never make a triangle. So the third side, when this is the case here, the third side x must be greater than 7. So if we'll if we'll go in a cyclic way and this side is again 5, then the
सर
third side of the triangle will be greater than 7. क्या बोल रहे हो बताओ?
सर ये 7 वाला समझ में नहीं आया.
मैं फिर से समझाता हूँ. देखो, जैसे एक 12 की स्टिक ले लो, ठीक है? 12 की साइज की स्टिक ले लिया तुमने?
हाँ सर.
बोलो, हाँ बोलो.
हाँ सर.
हाँ, एक 5 की स्टिक ले लो जिसको तुम 12 वाले पे एक साइड रख दो, ठीक है?
हाँ.
अब यहां से दूसरे एंड से हम 7 वाली स्टिक रखेंगे, तब ना एक दूसरे को ही टच करेंगे.
हाँ.
यानी कि अगर हम 7 की भी स्टिक लेंगे तो दे ऑल विल बी कोइंसाइडिंग टू ईच अदर, मतलब एक लाइन पे ही रह जाएगा.
हाँ.
तो ट्रायंगल नहीं बना ना हमारा.
नहीं.
और अगर हम 7 से छोटी लेंगे तो मिलेगा ही नहीं. 7 से छोटी स्टिक लेंगे तो 5 और 7 वाले मिलेंगे ही नहीं. देन यू विल नॉट हैव एनी ट्रायंगल.
हाँ.
तो इन ऑर्डर टू गेट अ ट्रायंगल, आपको 5 वाले को लाइन से थोड़ा ऊपर अगर हम करते हैं, जैसे यहाँ करते हैं, ठीक है? तो थर्ड साइड जो है, थर्ड साइड मस्ट बी ग्रेटर देन 7.
हाँ. हाँ. हाँ.
So that's what I was talking. The length of the third side must be greater than difference of two sides. So I'll write the result here that length of third side must be greater than difference of other two sides. Okay. So third side x, which I was taking at as an representative, I was representing the third side as x. The x must be greater than 7. Now what you can do, you can remove this stick and matlab not remove, rotate the stick as like this. And at every point you will be getting a triangle. And what you can see that the size of third side is increasing after rotation. And here we are getting a right angle triangle also. Then we kept on rotating the side of 5. And when the side of 5 is here at this place, so this is 12 and this is 5, then the third side must be equal to 17 in order to coincide on that line. So the third side cannot be greater than 17. So all the triangle which we can make from a side 5 and 12 can only be made if the third side is more than 7 and less than 17. Did everyone got the result?
Yes, sir.
Yes.
So if I'll ask you, is 2, 3, and 6, does these three side or do these three side not do these three side make a triangle?
No.
No, of course not. Because the difference of 6 and 3 is 3 and the third side is not greater than 3. Okay. So will 3, 3, 6 will make a triangle?
No.
No. And this also help us to find, if somebody is asking me how many triangle we can find with integer sides. Let's say someone is asking that how many triangles we can find with integer sides. So this question in the same situation. So how I'll take, I know that first two sides are 5 and 12. The third side will be greater than 7. That means 8, 9, 10, 11, 12, 13, 14, 15, 16. And it should be less than 17. Then we cannot go ahead to 17. So I can make actually how much triangles? 1, 2, 3, 4, 5, 6, 7, 8, 9. So the answer would be 9 triangles. Okay, with integer sides. And if it is not integer sides, you can make actually infinite triangles. Okay. So we actually talked about the condition with and sides and angles. Since we were saying that larger the side represents larger the angle, or larger the angle or larger the side. And this is true vice versa. And the only thing is to remember is it is not proportional. ठीक है, proportional कहने का मतलब कि if the sides is double, angle will not get doubled. But if two sides are equal, the opposite angles will also be equal. Two angles will be equal. So in any isosceles triangle, which I was defining or defined as, which I have defined as where there are two sides are equal. For any isosceles triangle, if these two sides are equal, these two angles are also equal. Okay. So if there is a triangle whose angles are 40, 40, 100. So you can say that this particular triangle is isosceles triangle. Okay. And if a triangle has an angle of 45, 4500, what kind of triangle will be this? Bolo? What kind of triangle is this with these angles?
सर ये ट्राइंगल नहीं होगा, इसका सम तो 180 से ज्यादा.
Exactly. This triangle doesn't exist because 45 plus 45 plus 100 is 190, which is not equal to 180. Okay. And the third thing is that if all the sides are equal, then if all the sides are equal, all the angles are also equal. So this was the case of equilateral triangle. And it can only exist if all the angles are equal. Yeah, that means 3x is equal to 180 or x is equal to 60. So all the equilateral triangle will have their angle as 60. So if you are drawing any triangle which has all the three angles at 60, 60, 60, it will always be a equilateral triangle. Okay. And if we take any side and if we try to draw a equilateral triangle with this, it will have all the angles same as 60. Okay. So these are the basic facts about triangle. Now let's go for properties. So the first thing that I'll be telling you here is about the area of triangle. Although we will have a very comprehensive lecture on mensuration, where we will be talking about area and volume. But before this, in order to understand triangles, let's understand about the area of the triangle also. So before we go to area of triangle, let me ask you, what is area? क्या होता है area? Anyone?
The space within the closed surface.
So if any closed surface is there, inside the closed surface, whatever space is there is called area. But you could have add one more word to it. Measure of space.
Yes.
So whenever we are trying to measure anything, let's say somebody asked you, what is your height? So you tell my height is 5 feet 3 inches. Or if somebody is asking you, how many water is there? So you tell it in either in liter or milliliter. If somebody is asking how much sunlight is there, How do you measure sunlight? किसी को पता है?
The intensity of light,
हाँ, उसको कैसे measure करते हैं? How do you
lux.
measure? Lux. So these are the GK facts you should be मतलब you should be knowing it. How do we measure pressure?
Pascal.
Pascal.
Yes. And what is 1 Pascal? How do we measure distance in kilometer? Whatever. Chalo, let's go back to the lecture only. We will not be talking about this right now. So, in order to measure anything, you need units. So, to measure a space inside any enclosed surface, we use a unit which is a square unit. Like whatever the distance measurement you are choosing, let's say this particular side is 1 centimeter. So the entire space which is being covered by a square of side 1 centimeter, it will be called 1 centimeter square. So if you want to know how much space is there, you will just start putting all the 1 centimeter square inside it and try to find out how many boxes it is containing. So if it contains, let's say, total 22.5 box of such size. So the area of space would be 22.5 centimeter square. 2.5 centimeter square. So this is what area is. So if your if your space is regular, regular by what do I mean by regular is, let's say it is rectangle of side 5 and 3. So what we can see here is So what I'll do here is I'll divide the entire space in such boxes. And we can just count the number of boxes which lies inside the rectangle. 1, 2, 3, 4, 5, and there are 3 sets of 5. So what exactly we are getting is 5 plus 5 plus 5, which means 5 into 3, and this is 15 square unit. So whatever unit is this, you can take it meter or centimeter or kilometer, whatever it is. Yeah. So the area of this particular closed space, which is a rectangle, is 5 into 3, 15 square units. And we got the formula also that length time width or breadth is your area. Okay. So if we have a triangle as a part of rectangle, that means if I have a right angle triangle, which one side is H, one side is B, and this H is not hypotenuse H. And let's say it is A and B. So this particular right angle triangle can be visualized as half of this rectangle. And the area of rectangle we all know is A into B. And since this particular right angle triangle is half of the rectangle, so the area of this triangle is half of A into B. Any half into multiplication of their perpendicular sides. Okay. And if there is a triangle which is not perpendicular, like this, and then also we'll write two things: one, any side as base, and a perpendicular from the opposite vertices to that side, which will be called height. So if we'll make a rectangle out of it, so this particular rectangle will have the area B into H. We all know now. This will be B into H. And what we can visualize here is the triangle is half of the rectangle. How? The triangle is half of the rectangle. Is anyone able to see this result? And how this particular triangle is half of the rectangle? So by default, I have just drawn also that how it will be half of this rectangle. So this particular height is dividing the triangle into two parts. This part is equal to this and this part is equal to this. So there are two parts which are equal, which are not there in the triangle, and these two parts are together. So the triangle is basically half of this entire rectangle. So the area of triangle will be half into base into height. And you just need to remember here is this base and height are corresponding to each other. I'm just writing or giving you the restrictions also here because sometimes your question will be based on this also. So if there is a triangle which looks like this, and let's say this particular side is there, B is given, and a perpendicular is also given, H. So this will also be an H. Any height is H in a triangle. But this triangle will not have, area will not be equal to half into B into H. Why? Because B and H here are not corresponding to each other. Corresponding to each other. Okay. So
सर
हाँ,
सर ये समझ में कैसे आएगा वो दोनों कॉरस्पॉन्डिंग है कि नहीं?
corresponding का मतलब हुआ कि जिस बेस की हम बात कर रहे हैं उसी के ऊपर हाइट,
अच्छा अच्छा
उसके
हाँ सर ठीक
ऑपोजिट
है
वर्टेक्स से, ठीक है?
हाँ हाँ
So हाँ, so these two should be corresponding to each other. To each other. ठीक है? So it is okay now?
हाँ सर
Okay. So we are done with the area of triangle. Let's go back to the geometrical properties of triangle. Okay. So just one thing I wanted to introduce. Achha, okay. So I need to add one more, what we do call it? Auxiliary. नहीं. Theory के extension को क्या बोलते हैं? Does anyone tell me the name of the word which we annex?
Annexure.
Annex. Good. So the NX of the previous result is, and some of the NX of the previous result is, if you have, let's say, a parallel line. If you have a parallel line and one line has a base, one line has its component as a base, like this is particular base, that means B and C. And the third vertex lies on the other parallel line, other line of the same set of parallel line. Like, let me draw a few of the triangles here. जस्ट टू टेल यू हियर, मुझे इतना डिटेल में तुम्हें पढ़ाने की जरूरत नहीं है ना, बिकॉज एक सेकेंड, थोड़ा मैं पॉज करता हूँ रिकॉर्डिंग. So the NX of the lecture was that if we'll take two parallel lines and we'll take a base of a triangle on one line, and let this base is of size B, and we may take multiple vertices on the second parallel line for the same base. And let's name it A1, A2, A3, and so on. So all these triangles which are being made between these two parallel lines with a common base, all these triangles will have same area, which is half into base into height, because the base is common, and height for all the triangles will be same, which is the distance between these two parallel lines. So all the height, if we'll draw, you will get same height, same measurement, and finally you will get the same area for all the triangles. And see the fun fact, these two lines I may increase it till any direction, till any point. Let's go 1,000 kilometers far away from this, and still you will be getting a triangle whose area will be same as this particular triangle. Okay, so this was one annex of the previous theory that we have learned. So now, after learning a bit about the mensuration of triangle, let's go back to the geometry. Some of the geometrical facts that you need to learn here with respect to similar and congruent triangles. So what are similar triangles? Oh no, what are similar triangles? So similar triangles are those who look similar, or that means all the angles of the triangles are same. All these triangles are similar. And congruent triangles are those which are same in the all measurements, even with size. So similarity with equal sides. Similarity with equal size or equality, जो भी बोलो, is congruent triangles. So these two triangles are congruent if A, B, C, and D, E, F. So if these two triangles are equal, then angle A should be equal to angle D, angle B should be equal to angle E, angle C should be equal to angle E, D, E, F था ना, angle F, sorry. Angle C should be angle to angle F. And not only angles, we also should be getting equal sides, like AB should be equal to DE, BC should be equal to EF, and AC or CA should be equal to DF. So in such case, or if something is there, then we'll call triangle ABC is congruent or equal to DEF. And if ABC is a triangle and DEF is another triangle, where angle A is equal to angle P is equal to angle D, and angle B is equal to angle E, D and P. I should be writing in this way. E is equal to angle Q, angle C is equal to angle F, and is equal to angle R. So if such condition is there, and even if there is no equality among sides, then we will call it triangle ABC is similar, and the sign for similarity will be this, DEF. And just for the nomenclature or writing rule, you should be writing the similarity with respect to the angles. Like if ABC is, I'll write ABC is similar to DEF. I will not write that ABC is similar to EFD, even if the same triangle is there. So this two triangle is similar, but I'll not write in this way. So always write, or we'll write the similarity with respect to the angles. So I'll write the same angle which is equal, the same pattern, PQR. One of the uh, first result which I'll talk, if AC is, or in these two triangles, if not AC, let's say DF is 2 times AC. That means this is, if this is in 2:1, then all the other sides is also will be in 2:1. So if anything, any of the sides follows the any particular ratio in similarity, then it will call it ratio of similarity. Ratio of similarity is equal to 1:2 for triangle ABC to triangle DEF. Okay, so this is how we define similar triangles. The first we'll have say all the angles same to each other, and we will also have ratio of similarity. So there are other results also. Let's do it in next class. Okay. Uh, and but next class will be covering a little more things. Today I have to go somewhere, so I'll be stopping here. But till then, you just remember these two. But if you someone wants to go ahead with the lecture, you can watch the previously recorded lecture in the which is given there in the YouTube playlist. Okay. तो इसको तुम लोग